Good day, everyone. I am Aiah Ubando.
And I am Raven Elias.
Before we start, we would like to ask you a few questions.
Are you aware of who Thomas Kuhn is?
Or maybe, do you know what a paradigm is?
I think you're quite clueless about these things.
So, do you want to know more about them?
Let us now take you on an adventure to Museo de Filosofia.
For you to know more about the fifth reading entitled The Structure of Scientific Revolutions by Thomas Kuhn.
Wait, let me stop you right there.
Take note as we go on this discussion, there will be keys that will be presented. And if you have finally gathered all the keys, there will be a revelation at the end of the discussion.
So let us now start. Presented now on the screen is an outline for you to be guided accordingly with the discussion. Please be guided that only chapters 4, 5, 6, and 10 are covered. Okay, now let us know more about Thomas Kuhn. Or Thomas Samuel Kuhn was born on July 18, 1922. In the year 1943, he graduated summa cum laude from Harvard University. After 3 years, he was able to obtain his master's degree in physics. After another 3 years, in 1949, he gained his doctorate degree in physics as well. By then, he was recognized as one of the most influential philosophers of science in the 20th century. One of his key contributions was the book he developed concerning the history of science, entitled The Structure of Scientific Revolutions. This is centralized on how we look at the philosophy behind science and how science itself develops and progresses.
Digging in deeper with the development of this book, Kuhn was greatly curious with the conception of the out-of-date scientific theory and practice. Thus, this book came upon. The first draft was then published in 1962 in the International Encyclopedia of Unified Science, which is a series of published works that deals with the general problems of the philosophy of science. The flow of the book also heavily revolved around the word paradigm, which is a vital concept of his. To formally open the discussion of the book's main points, I would like to start off with Kuhn's alternating phases. Baka tanong mo kung ano ang alternating phases. Ang ibig sabihin nito ay mayroong sistema ang siyensya. Kumbaga, meron siyang steps. Take note that we are talking about the natural science in this matter. As stated by the Oxford Languages, natural science is a branch of science that deals with the physical world like biology, physics, chemistry, and the like. And then, going back to the pattern of alternating phases, it simply means that science experiences certain stages in their becoming. These phases are namely pre-science, normal science, crisis, and lastly, the scientific revolution. So let me give you a run-through of these stages for you to further digest the chapters that will be discussed later. For the pre-science stage, it talks about arguments as people are in constant debate over theories and fundamentals. In this particular phase, the paradigm is not yet developed or matured. Beliefs among scientists are different, that's why there's no concept that's there yet to be accepted or proven. There are conflicts everywhere as scientists are having a hard time working together. The paradigm in question is literally starting from scratch. For the next phase, which is the normal science phase, it deals about the time where there is now a paradigm that is somewhat established. As Kuhn stated in the introduction, a role for history. In this phase where scientists invest most of their time and fill in the gaps with their new knowledge. On to the next phase, which is the crisis phase. In here, scientists are now doubting their own paradigm. There is the sense of losing that confidence from their gathered data. And in this stage, the scientists are now becoming aware of their paradigm and they finally become critical. For what sense, you may ask? Because they will now take things seriously, and they will scrutinize the data and the information that they have. The paradigm will now then develop. Lastly, the scientific revolution. In this phase, the paradigm that is concerned will be forsaken or maybe accepted. If the old paradigm was thoroughly forsaken, there will be a paradigm shift or a paradigm change. So yeah, these are the stages that science undergoes according to Kuhn. Wow, will you look at that? We have earned the first key. Well, this is where the real journey begins, for we will now open the doors towards chapter 4, 5, 6, and 10. I will now give the floor to my partner, Raven Elias.
Thank you, Aiah. In the chapter 4 of this book, Thomas talks about normal science. According to him, normal science is a day-to-day research that scientists conduct in order to fill in the gaps in the scientific knowledge that are found within the paradigm. To put it simply, as was said by Aiah a while ago, it is the activity in which most scientists spend their time in knowing what the world is like based on the assumption that the scientific community knows. We can also see that in this book, he mentioned the terms normal research results and normal research problems. The first term, normal research results, actually refers to the scope and precision of which the paradigm, which refers to accepted model or pattern, can be applied. As for the normal research problems, Kuhn states that these problems require the solution of all sorts of instrumental, conceptual, and mathematical puzzles.
Puzzles? Why are we even talking about puzzles?
Well, we can see that normal science is not as normal as it sounds like. It also has a challenge. And this challenge is to test whether a scientist is skillful enough to solve a puzzle that has never been solved before. To continue, Aya, can you read an excerpt from this chapter?
Sure, Rave. As Thomas Kuhn said, the terms puzzle and puzzle solver highlight several of the themes that have become increasingly prominent in the preceding pages. Puzzles are, in the entirely standard meaning here employed, that special category of problems that can serve to test ingenuity or skill in solution.
So if you're wondering what a puzzle has to do with science, let me explain it further. According to Kuhn, a puzzle contains a special category of problems that can serve to test skill in solution. We all know that in solving puzzles, there is always an assured existence of solutions. When solving one, some of us may think that it is impossible to put hundreds of puzzle pieces together to create a picture or an image, but it's actually not. Whether it takes hours, days, months, or even years to solve a puzzle, there will always be a solution. And this idea is actually similar to the puzzle solving concept which Kuhn was referring.
Wait, Rave, may I ask, what if a circumstance arises and it deals with the cure for cancer? Or maybe the design of lasting peace? Can they be solved using that puzzle?
Good question, Aya. Let me read another excerpt of Kuhn from this chapter. On the contrary, the really pressing problems, examples given, cure for cancer or the design of lasting peace, are often not puzzles at all, largely because they may not have any solution. Consider the jigsaw puzzle whose pieces are selected at a random from each of two different puzzle boxes. Since that problem is likely to defy even the most ingenious of men, it cannot serve as a test of skill and solution. In any usual sense, it is not a puzzle at all.
Oh, so that means the very essence of such puzzles is that they are solvable. So what if a paradigm is really not solvable? Then it will not be regarded as a puzzle?
Kuhn again has the answer for that, Aya. He said that to do that, however, would have been to change the paradigm, to define a new puzzle, and not to solve the new one, old one. Furthermore, Kuhn describes puzzle solving as the normal or everyday activity of scientists, which I mentioned earlier as normal science, which consists of problems which are believed in advance to have a solution, using the paradigm as a guide. But what exactly is a paradigm? Care to share, Aya?
Okay, so let us dive right into Chapter 5, The Priority of Paradigms. According to Kuhn, a paradigm is a universally recognizable scientific achievement that provides model problems and solutions to a community of practitioners. In short, it is just a model or pattern used as a guide by scientists to solve different problems they encounter in the course of their experiment and investigation. Para mag-grasp natin yung thought process na to, a paradigm or sometimes a disciplinary matrix, as was said by Kuhn, is simply a stockpile of knowledge. Here lies different facts, theories, concepts, laws, assumptions, instruments, materials, and the like.
Oh, para siyang isang guide as a science progress.
Yes, and apart from that, it also guides, ayun nga, as was said by Rafe kanina, as research in the absence of rules. Yes, you heard it right. A research can still proceed even without rules. In fact, the lack of interpretation of rules will not at all prevent a paradigm from guiding research. How, you ask? Well, scientists work from models acquired through education and through exposure to the literature without even knowing or needing to know what characteristics have been given to these models. The status of a community paradigm, which will be discussed later on, since scientists do it this way, there is no need for an actual set of rules. The reason why normal science can still be determined even without the intervention of rules is because, first, it is quite difficult to discover rules that have guided particular normal scientific traditions. And second, paradigms are rooted in the nature of education. Concepts, laws, and theories aren't learned by scientists by themselves, but rather, these are encountered from the start that displays them with and through their applications. But wait, let us shift our attention towards the process of learning a theory. I'll now read an excerpt from the book. Kuhn said that scientists, it should be already be clear, never learned concepts, laws, and theories in the abstract and by themselves. Instead, these intellectual tools are from the start encountered in historically and periodically prior unit that displays them with and through their applications. A new theory is always announced together with applications to some concrete range of natural phenomena. Without them, it will not even be a candidate for acceptance. To illustrate what I have said, imagine this. As a student proceeds from his freshman course and to his doctoral dissertation, the problems assigned to him became more complex and less completely precedented. But they continue to be closely modeled on previous achievements as they are the problems that normally occupy him during his subsequent independent scientific career. Kumbaga rito, yung mga scientists, inaaral nila ang isang theory in a way na meron silang isang proseso. One step at a time, parang ganon. At kung hindi man aligned sa field nila yung isang concept or theory, pero mas may insights naman sila kumpara sa iba. Parang better than layman's term, ika nga ni Kuhn.
So are you saying that it's much better to substitute rules with paradigms?
Yes, Rave. Actually, Kuhn said, without rules, it is easier for scientific communities to accept particular problems and provide solutions. It also makes scientific fields easier to understand when you do not have to follow a specific guideline or set of rules. Here's another particular excerpt from his work. Normal science can proceed without rules only so long as the relevant scientific community accepts without question the particular problem solutions already achieved. Rules should therefore become important, and the characteristic unconcerned about them should vanish whenever paradigms or models are felt to be insecure.
So rules are not really needed at all?
Yes, rules are only needed if and only if the paradigm is insecure. Yung parang meron pa siyang notable gaps.
It's still a little confusing for me.
No worries, Ray. I'll help you with that. Using an excerpt from Kuhn's work, just try to picture that there's an investigator who wanted to learn about what an atomic theory is. by asking a physicist and a chemist whether a single atom or helium is or not a molecule. So when the investigator asked the two of them separately, both of them answered without hesitation. But the thing is, their answers are not the same. Bakit? The chemist answered that the atom of the helium was a molecule because it behaved like one.
With respect to the kinetic theory of gases.
On the other hand, for the physicist, the helium atom was not a molecule because it displayed no molecular spectrum. So presumably, both the chemist and physicist were talking about the same thing. But the thing is, they were viewing it differently through their own research training and practice. Since they have different specialties, their experience in the problem solving told them what a molecule must be, whether it is or it is not a molecule. They might have the same experiences, but they did not the same thing. So with this example, we can see that substituting paradigms for rules makes the diversity of scientific fields and specialties easier to understand. Thus, without the presence of rules, scientific discoveries would not be restricted and limited, and paradigms would have different applications depending on the field and specialty, which will make it easier to use.
Oh, that's an impressive illustration, Aya. Thanks for elaborating it clearly. So now, why don't we proceed to the next chapter?
Sure, take it away, Ray.
Whoa, will you look at that? You have earned another key. Great job. You're a step closer to the final revelation. So for chapter 6, we will talk about two things. But first, we'll talk about discovery. Normally, we would perceive discovery as the process of finding out something that has never existed before. So for an instance, if we encounter something remarkable, we may ask things like who discovered this and when was it discovered? We may use the discovery of oxygen as an example. We may ask, was it Priestley or Lavoisier who discovered oxygen? And when was oxygen discovered? But answering this question is not as simple as you might think. According to Kuhn, discovery is not the sort of process about which the question is appropriately asked. So saying that oxygen was discovered by enduring is misleading. This implies that discovering is an effortless act. We can see that discovery is not the simple process of determining which date and who uncovered a particular object or event. In fact, discovery is a complex event. And we can determine a discovery by three things. First, if an awareness of an anomaly is present. If you're wondering what that is, an anomaly refers to the crisis in science that arises when confidence is lost in the ability of the paradigm to solve particularly worrying puzzles. So, to put it simply, an anomaly is the basis for most discoveries in the scientific field. Through an anomaly awareness, conceptual categories are adjusted and an anomaly is predicted.
Oh, an anomaly? It is a problem within a paradigm that scientists are having a hard time solving. If I'll connect it to the puzzle concept a while ago, it simply means that it is the mismatched piece.
Yes, that's right, Aya. Second, there must be a gradual and simultaneous emergence of observational and conceptual recognition. And lastly, there must also be a consequent change of paradigm categories. So to understand it better, we will be using the discovery of the Leyden jar as an illustration of these characteristics. So the Leyden jar, it is actually a device used to store electricity. When it began, there was no single paradigm for electrical research. Instead, there were theories. However, these theories derived from accessible electrical phenomena were in competition, and unfortunately, none of them succeeded. With this failure, several anomalies that provide background for the discovery of Leyden jar arise. Later on, one of the competing schools of electrician took electricity to be a fluid, and in this concept, led a number of men to attempt bottling the fluid by holding a water-filled glass vial in their hands and touching the water to a conductor suspended from an active electrostatic generator. On removing the jar from the machine and touching the water with their free hand, each of these investigators experienced a severe shock. However, these experiments did not provide electricians with the Leyden jar. The device they used emerged more slowly through the emergence of observational and conceptual recognitions. They had to learn that the jar required an outer as well as an inner conducting coating. They also have to learn that fluid is not really stored in the jar at all. In the course of their experiment, they were introduced to several other anomalous effects, which led to the emergence of the Leyden jar. These experiments were also the ones that became the grounds for the revision of the fluid theory and provided the first full paradigm for electricity. In this example, we can see how these characteristics are built into the nature of the perceptual process itself. Moving on, we'll now talk about what a paradigm change, also called a paradigm shift, is. From what Aya mentioned earlier, a paradigm is a scientific achievement that provides model problems and solutions to a community of practitioners. So if we put paradigm and the word change together, it will be the transition process of a field from the old to the new paradigm, while improving the new paradigm to maturity. So to put it simply, a paradigm change is just the further development of a paradigm. It can be the construction of elaborate equipment for, or the development of esoteric vocabulary and skills, or even the refinement of concepts. Though through this process, an old paradigm is sufficiently replaced by a new one. But what does paradigm change have to do with anomaly? According to Kuhn, an anomaly is usually an occasion for paradigm change. So the more precise and accurate a paradigm is, the more it provides a sensitive indicator of an anomaly. Now, let's talk about the effects of a paradigm change. Do you have an idea of how paradigm change creates a significant impact on the world, Aya?
Well, in chapter 10, the effects of paradigm change or shift is discussed. When a paradigm changes, the world changes with them. How? Actually, it is just like being transported to a different planet. Imagine what things would be in a different place and environment. Of course, familiar objects will be seen in a different light, and it is possible that some unfamiliar objects may appear as well. So in short, paradigm change causes scientists to see the world of their research in a different perspective. And this leads to scientists adopting new instruments and looking in new places. At times of revolution, when the normal scientific tradition changes, the scientist's perception of his environment must be re-educated. After doing so, the world of his research will seem just like the one he had inhabited before. According to Kuhn, scientists who embrace a new paradigm are like a man wearing inverting lenses. Try to imagine a person who puts on goggles fitted with inverting lenses. Naturally, he would see the entire world upside down, right? It would be different from the vision he's been used to seeing. But when he finally manages to deal with his new world, his entire visual field flips over and objects will be seen as they had been before the goggles were put on. Additionally, here is an excerpt from Kuhn. The period during which light was sometimes a wave and sometimes a particle was a period of crisis, a period when something was wrong and it ended only with the development of wave mechanics and the realization that light was a self-consistent entity, different from both waves and particles. So sa excerpt na to, mapapansin natin na may panahon ng krisis sa siyensya. Nag-develop lang siya ng tuluyan noong nagkaroon ng wave mechanics at nagkaroon ng kamalayan na isang self-consistent o walang gulo na entity ang light.
Oh, so it's like having a change of perception.
Exactly. In this chapter, Kuhn also states that the change of perception would make the history of science a lot more reasonable. On top of that, a shift of perception also leads to paradigm change. An example of this would be the time when the Copernican system encountered the moon. At first, they thought the moon was just a planet, but when they changed their perception, they found out the moon was actually not a planet. Another illustration was during William Herschel's discovery of Uranus. A number of astronomers perceived Uranus as a star. But after 12 years, when Herschel first observed the planet using a much more improved telescope, he noticed something. he detected that Uranus had an apparent disk size, which is unusual for stars. So, what he did was he disclosed the planet's motion among the stars and announced that Uranus was a comet.
But Uranus is not an actual comet, right?
Yep, and only after several months of attempts to fit the observed motion to a cometary orbit, Lexell suggested that the orbit was probably planetary. In short, they found out that Uranus was neither a star nor a comet. It was a planet. Since there was an anomalous playing card that could no longer fit to the perceptual categories of a star or a comet provided by the previous paradigm, they decided to shift their perception, and this led to them seeing Uranus as a planet.
Oh, so shift of perception really does lead to paradigm change.
Uh-huh. Actually, embracing a new paradigm is a matter of confronting the same ideas and concepts. But the twist here is that these concepts and ideas are transformed true and true in many of their details. So in accepting a new paradigm, data, instruments, and concepts are still kept in mind by the scientists. It just so happens that they are used in a different way in a different environment as well. So like what I said, paradigm change simply causes scientists to work in a different world. This can be actually seen during the years when John Dalton undertook the investigations that led finally to his famous chemical atomic theory. But did you guys know that Dalton was not actually a chemist? Instead, he was a meteorologist investigating the physical problems of the absorption of gases by water and of water by the atmosphere. And because his training and specialty was different from the one he was trying to investigate, he approached these problems with a paradigm different that of contemporary chemists. And when it came to a point where he had to measure sizes and weights, of the various atomic particles in his experimental mixtures, he finally turned into chemistry. With this, he was able to assume that atoms could only combine one to one or in others some whole number ratio. This assumption allowed him to determine the sizes and weights of elementary particles, and it also made the law of constant proportion a tautology. For him, any reaction in which the ingredients did not enter in fixed proportion was ipso facto not a purely chemical process. And this law, that experiment could not have established before, became a constituent principle that no single set of chemical measurements could have upset. To most chemists, Dalton's paradigm had implications far wider and more important than a new criterion for distinguishing a mixture from a compound. What chemists took from Dalton was not new experimental laws, but a new way of practicing chemistry. He himself called the new system of chemical philosophy. With this, we can say that Dalton encountered anomalies. He approached their problems with a new paradigm.
Wow, okay. Well, look at that. Since you persevered up to the last chapter, you got another key. Since you have collected all the keys, the doors of revelation are finally opening up.
Good job, everyone. So, to conclude, after all these chapters we have discussed, let us know the conclusion of Kuhn behind this book.
First, as per with our overall understanding of what we have both read, Kuhn regards his view in science as incommensurability.
You may ask what incommensurability is. It means there is no common measure or standard.
So, it simply boils down to you can't really put the two paradigms into comparison.
You can't say that one is better than the other.
Additionally, again, as per our own understanding, with regards with this book, is that Kuhn views science as something that is adaptable to changes.
And that concludes our discussion. We hope that you learned a lot and you have enjoyed our adventure. Till our next destination.